Find the area of the region that lies inside the circle r equals 1 and outside the cardioid r equals 1 minus cosine of theta. So let's start by graphing these two bad boys right here. The circle r equals 1, that's our favorite graph, right? Centered around the origin, radius of 1. It's our unit circle. And the cardioid r equals 1 minus cosine theta. Well, at theta equals 0, cosine is 1, so r equals 0 at that point. At theta equals pi over 2, cosine of theta equals 0, so r equals 1. So we have up here, and then r equals 2 when cosine equals pi, because cosine of cosine of pi is negative 1. 1 minus negative 1 is 2. And we know that the cardioid is in the shape of a heart and is symmetric. This particular cardioid is symmetric about the x-axis. So we know that must look something like this. And the area we're trying to find is outside this cardioid but inside the circle, which leaves this little area to be our area that we're interested in. Let's find the intersection points of the two graphs. So 1 equals 1 minus cosine of theta when cosine of theta equals 0. When does that occur? Well, if you take a peek at your unit circle, which you should know by now, by the way, you have theta equals pi over 2 and theta equals 3 pi over 2 as the points where your theta will be equal. Except if we use those two as our bounds, we would get the area circling here, except that's not what we want. We want the area from here to here. So how do we do that? Well, there's ways to rewrite angles to express the same angle in a different way. If we want to start from the bottom here and go all the way up, which one do we rewrite? Well, we rewrite 3 pi over 2 as what? We rewrite it as theta equals negative pi over 2. Same angle, just written in a different manner. Now let's set up the integral. We determined that our bounds would be negative pi over 2 to pi over 2. So what's the integrand? Well, we start off with 1/2. What's r1? Well, r sub 1 is the circle r equals 1. So that one is the larger of the two in that particular range. So then we have 1 squared minus the quantity 1 minus cosine of theta squared, because that's our smaller radius, and that is our setup. If we double the area on the top half of the graph, we will get the same thing because of symmetry about the x-axis, and if we simplify out the cardioid's equation squared, we get 1 minus 2 cosine theta plus cosine squared theta. Combining like variables and simplifying out our terms will leave us with the integrand 2 cosine theta minus cosine squared theta d theta. Now at this point we don't really know how to integrate cosine squared theta effectively directly, so we have to find an alternative approach to make sure that we can integrate this. We don't need our calculators, but there is a way to rewrite cosine squared of theta to be easier to integrate using trig identities. The identity that I'm referring to is cosine squared theta equals 1/2 cosine 2 theta plus 1/2. Simplifying out, we get the integrand to be 2 cosine theta minus 1/2 cosine of 2 theta minus 1/2 d. Taking the antiderivative gives us 2 sine theta minus 1/4 sine 2 theta minus 1/2 theta from 0 to pi over 2. Substituting in our bounds will give us 2 sine pi over 2 minus 1 over 4 sine pi minus 1/2 times pi over 2, and all minus 0, which comes out to be 2 minus pi over 4, which is approximately 1.215, which is the area between those two curves.